My president, right now I am chairman of the Aerospace Division Board of the Institution of Engineers, which is also promoting through the R&D committee of the Institution of Engineers, new initiatives for the students to come up with innovative projects. So one of them is supporting the student-built satellite projects. So last slide in my thing will cover that thing. But this was very recently I have been to Uttarakhand. As you know, the first sounding rocket was launched from Tumba around 1963 November, and then it is in 50th year. Very recently they had a commemoration launch and 100+ missions. It is now more than 110, and 58 missions are planned during the 2012-2017, 33 satellites and 25 launch vehicle missions. And then 20,000 crores is the planned outlay for this program of these 58 missions up to 2020 or so. Then the more than 5 industries are participating, focused on total system delivery from now on, as against the manufacturing and integration support from industries at present. The bottom last line, very colloquially they call it barbershop operation. That is, a very limited thing only is contributed by the industry, but that will change now. The other part, mission for communication, remote sensing, meteorology, space science and technology development for payload recovery from orbit, reusable launch vehicles and serviceable satellites, that is still not attempted. Serviceable satellite is still not attempted. Human space flight, some experimental facilities are being created. At least enabling technology development is going on. But the serviceable satellite is something which is, the robotics, because part of your theme is on robotics. So how to refuel the satellite in orbit after it is depleted, tanks are depleted, changing the batteries, sometimes changing the solar panels. It has been attempted by astronauts in the context of the Hubble Space Telescope. They changed the solar panel to be refitted like that. But the thing is, the last few of those goals are yet to come, but that is going to give big commercial return, serviceable satellite. The other specialized missions for meteorology, climate monitoring, moon and Mars missions are in progress, because it's already ongoing. And then the Aditya, the solar mission, that may be another 2 years or so, I think the launch will take place. That will be most likely parked in something called the Lagrange points. There are stable points and unstable points. The Lagrange, the multi-body dynamics, in the astrodynamics you will see those things. So that will be having a vantage point to look at the sun continuously. And the missions include, I think, study of sun, corona, many other things. So these are, I think, one of the student-built satellite proposals very recently at Bhopal, I think the Maulana Azad NIT, they are coming with the Azad 1 satellite, and the payload they are contemplating is on solar corona studies. But it is in ultraviolet, and also making the optical instrumentation is very, very complicated. So Dr. Jayant Narlikar and many others, they have approached for getting help from the Inter-University Center for Astronomy at Pune, and also Physical Research Lab, Ahmedabad, then the Solar Observatory at Udaipur, and our Indian Institute of Astrophysics, many others are supporting that idea. The space technology education and supporting R&D in academic industry through RESPOND. This is something which I think many of you may be aware, that there is a sponsored research project fund created in ISRO with approximately 1% of the annual budget is kept apart for the student and research projects in the academic institutions. So some of these things can be harnessed for at least building small components for the satellite missions, and support for student-built satellite. It is primarily by free launch opportunity. That is, ISRO is giving free launch. So today, the launch cost is prohibitive. If you go outside India and then get a launch, it will cost maybe $1 million or at least $500,000 you have to pay, which is now coming free. But you have to become a worthwhile person. Your proposal should be accepted, should be something unique and innovative, and there will be a rigorous review process by ISRO to clear your thing, and at the end also put it in the manifest. So now I think as he rightly said, 7 or 8 student-built satellite activities which are going on in India. Out of them, some have been already reviewed and cleared, and they may be manifested for the launch this year end or next year, depending on the polar missions and the other available missions to carry these payloads. And the international collaboration and joint projects, we had the Indo-Canadian, there was a joint meeting at VTU Belgaum, and I think your college also was participating in that. So they are looking for the cluster of satellites to do something worthwhile for the humanity. All over the world they want to take this thing. So many countries can participate. So on Mr. Pimbrikar, and I think they are also visiting India soon. And many institutions in the country, they are talking to them. So, but disaster management, how to put a cluster of satellites to do service for that requirement, I think that is one of the key components in that proposal. And of course, this is our current ISRO launch vehicle. SLV-3 is now only a museum piece. And then the other ASLV also has been retired. So of course, they are the two things, when we carried the big L boats, and also a lot of technology problems we solved, and then we have come up to BSLV, which has become the workhorse vehicle, and also the GSLV, which has been recently successfully launched in the December. So now with the totally indigenous capability end to end, but GSLV will also go through a Mark III version, which will doubling the payload capability, which is also capable of carrying the human spaceflight type of vehicles later on. And you will see the extreme end, that is the GSLV, and also Mark III, and this is the PSLV at the extreme, right? So this was in our Indian Technology Congress, that time we had kept the mock-up model. You see, the even to come to this stage, from cartoon stage to completed project, I think in a launch vehicle it takes about 10 to 12 years and not less than 50 to 60,000 man years. So I think that is the kind of effort and sweat it has gone into in all these things. And the other part, satellites for other space agencies launched by India, you will see a big list. This is available in the ISRO headquarters, the Director of Publications and Public Relations. You can see you can request for getting all the pamphlets here, maybe before you go out. And you can even get those pamphlets from our Director of Public Relations. So it gives a summary of many of the things which we are doing. Some were paid, some were free for other countries, including Singapore, Canada, in Europe, in US, many other countries we have done, Korea also we have done. And these are all, the sizes you will see, 1 kg, all kinds of ranges. So from Argentina, one Pegunsat team came. I think there were some 5 people only, in the suitcase they brought everything, and then, including the checkout, everything, and then, after the launch, one went to Europe and another went back to South America, so for the orbital operations. So it is quite possible. And this ISRO, unlike other people, we work on the decade profile and also sometimes long-term planning. So a program is always a long-term, and they are all project types, and then with a definite cost and time frame, and the end objectives have to be fulfilled. So you will see the Earth observations is one of the driving things, then satellite communication the second one, and then the space science and the new technologies and environmental monitoring. This is like what you would say, it is a window to the new knowledge, space science. The unsolved problem like the origin of life, origin of universe, origin of solar system, and then even there are unsolved problems like the whether the asteroid and many other things, to capture, or how they got into that kind of trajectory. Many of those things are still not solved fully. So one mission where the Japanese have sent a satellite which went to one of the asteroids named Itagawa, and then the Hayabusa was the mission, and then it will go and land on that small body. On that they took sample, put it in a container, and then it has to come back. It was to be done by electric propulsion. So that unfortunately there were some small mishaps, but in spite of all that they returned back the sample. Only the container did not have enough quantity of material, but they still had traces of what was sampled there. So they have got the thing done from asteroid. That kind of thing also is there.